Hello everyone, welcome to the third part of linear regression algorithm. In the second part, we are introduced with the topic gradient descent, which we got by plotting the cost function versus theta 1 values. And our aim is to find out the model which is having the cost function value near to the global minima. Now, how to reach that global minima? Suppose we are at this point, the cost function is having this value corresponding to this value of theta 1. Now, how to reach from this point to the global minima is the aim. In that case, the model will be the best one for our predictions. Now, how to reach from this point to the global minima? For that, we are having an algorithm called as the gradient descent algorithm, with the help of which we will reach the global minima by continuously updating the values of theta 0 and theta 1. So it says repeat until convergence. This is a statement of this algorithm. Now, how does the values of theta 0 and theta 1 are getting iterated in each steps? So this is the expression with the help of which we update. So theta j is equals to theta j minus alpha times partial derivative with respect to theta j of the cost function, which involves two parameters theta 0 and theta 1. Now here we know that these are our parameters. J will be taking two values 0 and 1 because we have two parameters theta 0 and theta 1. Here alpha is called as the learning rate, which is nothing but with what speed we will be moving downward towards the global minima. That speed is determined by the value of this alpha. Usually we take the value of alpha, the learning rate, equals to 0.01, and this particular term is a partial derivative of the cost function with respect to the two parameters that it has, theta 0 and theta 1, which is basically the slope in the direction of theta 0 and theta 1. Now consider a scenario. Let us say this is the gradient descent curve which we are having, and we are currently at this position. Our aim is to reach to this global minima. So what we do, first we take some values of the learning rate. Like first we decide with what speed we need to descend along this curve to reach this point. If you consider, so this is, let us plot this j of theta 1 versus theta 1. So this is the current value of theta 1 and we have to reach to this point. So this value of theta 1 we want to approach. That means we have to continuously reduce the value of theta 1 to reach to the global minima. So if in this expression here, if I take j equal to 1, what we get, theta 1 is equal to theta 1 minus alpha times partial derivative with respect to theta 1 of the cost function. This is the slope, correct? So here if I plot a tangent, let us say this is a tangent at the point. So this is having a positive slope, so this value is positive. So what we get, theta 1 as theta 1 minus alpha times some positive value. So this is how we are iterating theta 1. You can see we are subtracting some positive term from theta 1 each time. That means we are approaching the global minima. We can have the other case as well. So let us consider the second case. So it will be like theta 1 and j of theta 1. This is the gradient descent curve. And now let us say we are at this point. If we draw a tangent at this point, so that it will be having the negative slope, correct? Since the slope is negative, and again if we write this expression theta 1 minus alpha times, and now the slope is negative. So negative times negative becomes positive. So theta 1's time some positive value we are getting. So from here only we can see theta 1 how it is getting updated. It is being increased by adding this additional value, which is alpha times the slope. So currently our theta 1 is this, and we have to reach this point. So currently continuously we need to increase the value of theta 1, and this is how it is increased. So this is the meaning of the gradient descent algorithm, and this is how, using the partial derivative learning rate, we keep on iterating the value of theta 0 and theta 1. Learning rate, in the animated first video I have shown you what does it mean. The speed with which we approach the global minimum. If we take learning rate value to be a larger one, we may skip the global minima, and if we take too small value for this alpha, it will take forever to reach this global minima. So in either cases, that will not be a good thing for us, for our model as well. So we keep its value to be usually 0.01, which is neither too small nor too large. Now, let us expand this expression and let us find out what is this theta 1 and theta 0 value. So theta j, it is updated using this expression, theta j minus alpha times the partial derivative with respect to j of the cost function, which is having two parameters, theta 0 and theta 1. Let me also write the expression for the cost function. So j of theta 0, theta 1, we know it was 1 over 2 times m summation going from 1 to m. And here we are having the mean squared error term, which was h theta of xi, the predicted minus the actual value yi square. So here, if I take the derivative of the cost function with respect to theta 0, what we will get? 1 over 2m is a constant. Now here a square we are having. Let me write some note as well. Note. If we have to differentiate d over dx of some term, let's say x minus 1 whole square. So what we do? We take 2 in the front and then we get x minus 1 raised to 1. Correct? So here also the power is 2. So it will be taken into the front. Summation I going from 1 to m, and here we will get h theta of xi minus yi, and the power will be 1 here. So 2 and 2 will get cancelled. So we get the partial derivative as 1 over m summation from 1 to m h theta of xi minus yi. This is with respect to theta naught. Now, with respect to, if we find out the derivative with respect to theta 1, what we will get? 1 over 2m, correct? Again, 2 will be in the front, summation going from 1 to m. Here we were having h theta of xi minus yi, and one more term we are having. If we see what is the value of h theta of xi, so this was nothing but theta 0 plus theta 1 time xi, correct? So if we take the derivative of it with respect to theta 1 of h theta of xi, what we will get? Theta naught, the derivative is 0 because it is a constant, and here with respect to theta 1 we are taking the derivative, so we will get this term only, xr, correct? So taking the derivative of h theta of xi with respect to theta 1, we are having xi. So here additional multiplication we have to do with xi. Hope you are understanding. This is the chain rule that we study in differentiation. Again 2 will get cancelled, and here we are having 1 over m summation I going from 1 to m h theta of xi minus yi times xr. This is the two partial derivatives. Now we can now rewrite again the gradient descent algorithm. So finally the gradient descent algorithm. In the expanded form we are writing here with respect to the both variable how they are going to change. So it says repeat until convergence, and the expression which we are going to get. First I will write down for theta 0. It is updated in the following ways. Theta 0 minus alpha times the partial derivative value we will write here, correct? So that is 1 over m summation from 1 to m, correct? And here we are having h theta of xi minus yi. This is our theta 0, and how theta 1 is updated. So it will be theta 1 minus alpha times 1 over m summation I going from 1 to m, again h theta of xi minus yi multiplied with xi. This is how the two values theta 0 and theta 1 are getting updated, and this will be the final gradient descent algorithm, which helps us finding the best fit model for our data by minimizing the value of the cost function near to the global minima. Thank you for watching.